Alright, this is example number 4. Okay, it is on using the method that is called cylindrical shells. So be reminded, our formula is here. When our axis of rotation is y-axis, this is our formula. If our axis of rotation is the x-axis, this is our formula. Be reminded that this first variable here, the x here, is actually the radius. And this one here is the height. Use the method of cylindrical shells to find the volume of the solid obtained by rotating the region bounded by y equals x minus 2 and y equals square root of x minus 2 about the x-axis. Okay, firstly we need to have an idea how the graph looks like. So we will sketch the graphs first. Okay, this one here is a line with slope 1 and y-intercept -2. The graph looks like this, straight line. Okay, and the other one is square root of x minus 2. What we are going to do is find the points of intersection here, because that will help us later on for our limits of integration. Okay, how do we find the intersection of these two graphs here? So we will have to equate both equations. So we will have x minus 2 equals square root of x minus 2. And then to solve that, we can square both sides. Okay, so this becomes x squared minus 4x minus plus 4 equals x minus 2, and then actually I can write this as x squared minus 5x plus 6 equals 0, and we can factor this into x minus 2 and x minus 3, and here x equals 2 and x equals 3. So this means this is 2 here, and this one here is 3. Alright? So be reminded, we are rotating this about the y-axis. Now, let's go ahead and draw the reflection of this region here. Okay, 1, 2. Roughly like that. Okay? And now the method, the cylindrical method is, cylindrical shells method says, that we are going to choose a strip here, a generic strip, and its width is actually dx, and we are going to rotate that strip, about the y-axis, so that we can form what we call a cylindrical shell. Looks like that. Now, our next question is, what will be the radius of this shell? So, the radius, of course, from there, from the axis of rotation to that point, that is what we call that is now the radius, which is actually x. And this, from here to here, we call it the height of our cylindrical shell. Let's go ahead and set up our solution to this. We have limits of integration 2 to 3, and then our formula says there is a 2 pi, and then the x, which is the radius, and now the height. It looks like this region is bounded by the two graphs, a line and a square root function. So, to find the height here, we are going to take this upper function, upper graph, minus the lower graph. Okay, so that means we will have the upper is square root of x minus 2, and then minus the lower graph, which is just x minus 2, and then dx. Okay, we already set up our solution to this. Okay, now we are going to deal with this. Okay, let's go to the next page. I will erase this so that if you have some questions later on, we can go up here and answer your questions. Okay, let's go to the next page. That was 2 to 3, and then 2 pi, the radius x, the upper function, which was square root of x minus 2, minus the lower function, which is just x minus 2, and then dx. Now, how do we solve this problem? So it looks complicated. We can actually use substitution method here. We call it U substitution. So I can let U to be this one here, x minus 2, because I have here another x minus 2. And if you are going to find the derivative of u, du, so the derivative of x minus 2 is just dx. Okay? And from here, we can solve this, find x. Okay, isolate x by itself, we will have x equals u plus 2. And because we already changed, we changed x to u, we can also change this limits of integration. So we'll say x equals this number here, lower limit, u equals, when we plug in 2 here, it's going to be 0. So x equals 3, plug in 3 here, u equals 1. So we have now new limits of integration. Okay, let's go ahead and use this new limit of integration, 0, 1, and then we have 2 pi. Actually, we can put it up front. And then this one here is the x. According to our substitution here, we have x equals u plus 2, so we can use this u plus 2. And then square root of x minus 2. X minus 2 is just a u, so that means it's just square root of u. And then minus, and then x minus 2 again is another u, so like that. And we change now to du. Okay, from here we can expand this, okay, multiply. So 2 pi, this is 0 to 1, u times square root of u. Actually, we know that square root of u means u to the power of 1/2. That means this now becomes u to the power of 3 over 2. And when we multiply this, this is minus u squared. When we multiply this, that's 2u to the power of 1/2. And when we multiply this, that's negative 2u. Okay, du. And now, we can now start integrating. So we'll use another color here. So 2 pi, and then the integral of u to the power of 3 over 2 is when we add 1, that's 5 over 2. So that's u to the power of 5 over 2, and then 2 over 5 here. And then u squared will be u to the power of 3 over 3. And then plus 1/2 plus 1 is 3 over 2. Multiply, divide by 3 over 2 as well. So it's going to be u to the power of 3 over 2. When you divide it by 3 over 2, it becomes 4 over 3. And then the exponent here is 1. 1 plus 1 is 2 divided by 2. So this will only be minus u squared. So we will evaluated or integrated from 0 to 1. 0 to 1 there. Okay. So we'll keep going now. Okay. So when we plug in 1 here to all of this u's here, this will only become 2 over 5. This will become 1/3. This will become 4 over 3. And this will be only 1. And then if we plug in 0 to all the u's here, that will just be 0. Okay? That's it. Now we keep going. 2 pi. Okay, that's 2 over 5 minus 1/3. This one here is 6 minus 5 is 1 over 15. And then this here is going to be 4 minus 3, which is 1 over 3. And when we add 1 over 15 plus 1 over 3, we will have 6 over 15. And then if we multiply, we will have 12 over 15 pi. And we can reduce it to be 4 over 5 pi and cubic units. So that's going to be our answer.